Miles and miles above your head are nearly 5,000 satellites, providing us with a constant stream of information. They help us navigate via global positioning systems, communicate and observe our world and outer space. They're also used for internet, television, radio, and gathering data for environmental applications, as well as map making, weather prediction, and more. So how do we get them there? We launch them into space on rockets. In the United States, most rockets are launched from Cape Canaveral Space Force Station in Florida and Vandenberg Space Force Base in California. Rockets are launched towards Earth's atmosphere at about 25,000 miles per hour to completely escape Earth's gravity. Rockets fly by jet propulsion, where large amounts of fuel, known as propellant, are burned. The propellant is mixed with an oxidizer, such as liquid oxygen, and combusts, ejecting a high-speed jet of gas with enough force to overcome inertia and gravity. Rockets carry their own oxidizer, which allows them to burn fuel in space, unlike, for example, engines in cars, which need oxygen from the air to combust. As the rocket loses weight from burning propellant and shedding empty propellant containers, known as stages, it speeds up. When it reaches the correct altitude, the rocket's inertial guidance system, an autonomous system that monitors position, velocity, and acceleration, guides the rocket via smaller jets or by redirecting exhaust, and the satellite is released. The spent rocket falls back to Earth. But why doesn't the satellite? The rocket's flight plan is calculated to position the satellite so Earth's gravity and the satellite's inertia counter each other to achieve orbital velocity, the speed where the satellite will continue to orbit without yielding to gravity. Satellites closer to Earth need a higher orbital velocity due to increasing gravity and other factors, such as atmospheric drag. Low Earth orbits range from 100 to 1,200 miles above Earth. For comparison, commercial flights are limited to about 9 miles. The International Space Station and Hubble Space Telescope are in this orbit. Medium Earth orbits put satellites at about 12,500 miles. Medium Earth orbits take 12 hours to complete and are consistent and highly predictable, perfect for global positioning system satellites. High Earth or geosynchronous orbits have an altitude greater than 22,300 miles, giving them an orbital period the same as Earth's rotational period, about 24 hours. Satellites here include many hundreds of television, communication, and weather satellites. Types of high Earth orbits include geostationary orbits, where the satellite is positioned over the equator so it overlooks the same spot, allowing it to observe an area over time, and highly elliptical orbits, or Molniya orbits, which put satellites on an elliptical track to observe the Earth's far north and south. For most satellites, higher altitude means they can stay in orbit longer. Satellites must occasionally reposition to counter drag from Earth's atmosphere, gravity, or avoid debris. But what goes up must come down. Satellites last, on average, only 15 years. Who can launch a satellite? In the United States, launch and flight permissions are granted by the Federal Aviation Administration's Office of Commercial Space Transportation, an agency within the Department of Transportation. Other countries have similar government organizations. As of January 1st, 2022, 4,852 active satellites are orbiting Earth, with 2,944 belonging to the United States. The closest competitor, China, has 499. Rocket launches are expensive, leaving them for governments and large corporations. However, others, such as research companies, universities, or private parties, can pay to have their satellites launched as well. The most common commercially available satellite is the CubeSat, a miniature satellite available for the low price of $10,000. Meaning, with a little work, you too can launch your own satellite. Thanks for watching.